Welcome back to the Deep Dive. Today, we are tackling a question that is, it's simultaneously the most intimate thing about you and the most elusive scientific mystery in history. What is your mind?
Right.
And maybe more importantly, where is it?
It's one of those questions that sounds so simple, right? Until you actually try to answer it.
And the floor just falls out from under you.
Exactly.
My first instinct, my gut, is to point to my head. I say, I'm in here. But as we went through the research for today, and we're going from ancient philosophy to modern chaos theory, it turns out I'm in here is a highly contested statement.
Oh, it is. And the answer has changed radically. It really depends on who held the power in science at any given time.
We've got a massive timeline to get through. We're going to look at the early days of trying to chemically analyze a thought. Then we'll move through the era where we thought humans were just stimulus response machines.
The behaviorists.
The behaviorists. Then into the computer metaphor, which I think most of us still kind of believe today. And finally, we're going to land on a new theory, one that suggests your brain isn't a computer at all, but a chaotic storm.
A dynamical system. That's really the destination here. And it completely changes how you view things like habits or learning or even your own personality.
But we have to start with the old guard. And I was surprised the whole head versus heart debate wasn't just, poetic. It was literal.
Oh, absolutely. If you go back to Aristotle, he was completely convinced the mind was in the heart. He looked at the brain, this, wet gray radiator-looking thing, and thought, well, that's obviously just a cooling mechanism for the blood.
Right. The heart was where the action was.
The heart had the heat, the action.
It's a great reminder that being a genius doesn't mean you're right about everything. But then you have Plato, his teacher, who was firmly team brain. And this sets up maybe the oldest battle in the book, nature versus nurture.
Right. Aristotle was more of a tabula rasa guy, the blank slate. Experience writes upon us. Plato believed we come preloaded with innate knowledge. And honestly, that tension between the hardware we're born with and the software we learn is still the central fight in psychology today.
So let's fast forward to when this actually became a science. Because for a long, long time, this was just guys in togas arguing. When did we decide to actually measure the mind?
1879, Leipzig, Germany. Wilhelm Wundt opens the first ever psychology laboratory.
This is the moment.
This is the moment psychology divorces philosophy and moves in with biology.
And Wundt's student, Edward Titchener, he takes this to America with a very specific, and I have to say, a very intense approach called structuralism. Reading about his methods, it sounds exhausting.
It was grueling. Titchener was trying to be the Mendeleev of the mind. He wanted a periodic table of consciousness. He thought if we could just break a thought down into its atomic parts, we'd understand the whole thing.
But you can't exactly put a thought under a microscope.
No. So he used something called rigidly controlled introspection. And we have to be really clear here. This wasn't just sitting in a chair asking, so how do I feel today?
No.
He trained his observers for hours to describe their experiences without using meaning words.
Oh, this is the stimulus error, right?
Exactly. If I hold up an apple and you say, I see an apple, Titchener would, kid you out of the lab.
You failed.
You failed. You were supposed to say, I experience a spherical patch of red with a glossy luminosity and a specific spatial intensity.
It's like trying to describe a song by just listing the frequencies in hertz. You're technically correct, but you've completely missed the music.
That's a perfect analogy, and that was the downfall of structuralism. It was incredibly subjective. If you say the red is luminosity level 5 and I say it's level 6, who's right?
There's no way to know.
There's no way to verify it. It was a scientific dead end.
So naturally, the Americans stepped in. We had William James and John Dewey, and they basically looked at this German obsession with structure and just said, who cares?
Enter functionalism. This is the classic American pivot. They didn't care about what the mind was made of. They cared about what it did.
The why instead of the what.
And you have to remember the context. Charles Darwin had just shaken up the entire world. So if you accept evolution, then the mind isn't just some luxury item. It has to be a survival tool.
Right. A giraffe has a long neck to reach leaves. Humans have complex memory too.
What?
Avoid getting eaten.
Precisely. Functionalism asks, how does memory help us survive? How does fear keep us safe? There's this great quote from Hugo Münsterberg, a psychologist from that time, that just sums it up. He said, "It is more natural to drink water than to analyze its chemical elements in a laboratory."
That's the whole vibe shift. Structuralism is analyzing the hydrogen and the oxygen.
Right.
Functionalism is just drinking the water because you're thirsty.
But even functionalism had a problem. It was still relying on people talking about their inner lives, and scientists were getting jealous of, the physicists and chemists who dealt with hard, observable facts.
And this triggers maybe the hardest swing of the pendulum yet.
Right.
We go from let's analyze feelings to feelings don't exist.
Yeah.
The behaviorists.
The black box era. John B. Watson and later B.F. Skinner, they wanted psychology to be a hard science, and since you can't see a mind and you can't see a desire,
Then you can't study it.
they decided those things shouldn't even be part of the equation.
This part has always baffled me. I mean, I know I have thoughts, I know I have feelings. How could a scientist look at a human being and say, nope, only your movements matter?
Well, this is where we have to clear up a massive misconception about B.F. Skinner. Most people think of him as the guy who believed humans were just robots, inputs and outputs, no soul, no mind.
Right, the pigeon guy.
The pigeon guy. But Skinner was a radical behaviorist, and radical here means getting to the root. Skinner never denied that you have thoughts or feelings.
He didn't.
No, he just reclassified them. To Skinner, thinking wasn't some mystical ghost process. He called it covert behavior.
Covert behavior.
He said, thinking is just an action you do inside your skin, the same way walking is an action you do with your legs.
Okay, hold on. So to Skinner, me doing math in my head is in the same category of event as me waving my hand.
Exactly. It's all physical. And his big argument was about causality. We usually think, I thought about cake, so I ate the cake. The thought caused the action. Skinner said, no.
No.
The environment triggered the thought and the action.
Ah, so this is the selection by consequences idea.
Yes. Just as evolution selects physical traits, the environment selects our behaviors. If you tell a joke and everyone laughs, that behavior gets selected and strengthened. If they stare at you in silence, it gets weakened. You aren't funny because you have an inner sense of humor.
You're funny because the environment reinforced your joke-telling behavior.
That's it.
It's compelling, but it feels like it strips our agency away. It reminds me of his criticism of the homunculus. Can you explain that? Because it's such a weird word.
It is a weird word. The homunculus is the little man. Skinner argued that if you say, I did this because my mind decided to, you're just imagining a little pilot inside your head pulling levers.
Okay.
But then you have to ask, well, how does the pilot decide? Does he have a tinier man inside his head?
It's little men, all the way down. An infinite regress.
It's an infinite regress. Skinner wanted to stop that, he said. Stop looking for the little man. Look at the environment.
But we couldn't stay there. I mean, as clean as that theory is, it ignores that we do process information. We don't just react. We plan. And then history intervened again.
Yeah.
World War II, technology, the rise of coding.
The cognitive revolution, this is where the computer metaphor just takes over the world. And honestly, it saves psychology from behaviorism.
Because suddenly we had a machine that did what the mind does.
Right.
It takes input, it processes it using rules,
Yeah.
and it gives you an output.
It was an irresistible metaphor. It allowed scientists to finally open the black box again. They could say, look, the mind is the software and the brain is the hardware. This is the computational theory of mind.
And this is still the dominant view, right? I think if you ask most people on the street, they imagine their brain is some kind of biological hard drive.
Absolutely. We talk about processing information, storing memories, retrieving data. It's all computer language. And central to this whole idea is mental representations.
This is a key term in the research.
Yeah.
Break that down for us. What is a representation in this context?
Think of it like a map. A map is not the territory, right? It's a symbol that represents the territory. The computer view says our brain is just full of these maps. You have a mental code for Apple, a code for grandma, a code for justice.
And thinking is just the algorithm shuffling those symbols around.
Shuffling them according to rules. Gary Marcus had a really good point on this about categories and rules.
Right.
He argues that to explain human intelligence, you need that kind of algebraic structure. For example, if I tell you a glorp is a new kind of fruit, and then I say I ate a glorp, you instantly know a ton of things. You know, I chewed it, I swallowed it, I digested it.
Because I have a fruit category and a rule that says fruits are for eating.
Exactly. You didn't need to see me eat it, you computed it. A simple association machine like Skinner's pigeon might struggle with that kind of instantaneous logic. So the computer model seemed perfect.
It explains logic, it
Okay.
explains math,
Okay.
but it feels a bit clunky for other things. And computers are rigid, they crash. They do step one, then step two. My mind doesn't feel like it's taking turns. It feels fluid.
And that is the crack in the foundation. We are now entering the new frontier dynamic cognitivism. There's a growing group of scientists saying the computer metaphor is fundamentally wrong because it ignores one crucial thing: time.
Time.
Real life happens in real time. A computer can wait for a download. A computer can pause. If a tiger is jumping at you, you cannot pause to compute the trajectory.
You just have to move.
You have to move.
The source material uses this really cool, slightly obscure example to explain this. The Watt governor. And I promise you listening, this is worth understanding because it totally shifts the paradigm.
It's the perfect counterexample to a computer. So, the Watt governor is a device from the steam engine era. Its job is to keep the engine speed constant. It has these two metal balls attached to a spindle. As the engine speeds up, centrifugal force throws the balls outward.
Like a spinning skirt.
Exactly like a spinning skirt. And as they fly outward, they are mechanically linked to a valve. So balls fly out, the valve closes, steam drops, the engine slows down.
And then the reverse.
Then the balls drop, the valve opens, engine speeds up.
So here's the million-dollar question. Where's the computation? Where's the decision to slow down?
And that's the trick. There isn't one. The governor doesn't measure the speed, send a number to a CPU, calculate the difference, and then send a command back. The angle of the balls is the information. The engine drives the governor, and the governor controls the engine. They're coupled in this continuous loop.
And dynamicists are saying we are the Watt governor. We're not a laptop processing data. We're a system that is constantly adjusting to the environment in real time.
Yes. There are no steps. There is just flow. And to map this, they use dynamical systems theory. Instead of a filing cabinet, I want you to imagine a landscape, a terrain with mountains and valleys.
This state space concept, visualizing this really helps me.
So imagine your current state of mind is a ball rolling on this landscape. A habit isn't a line of code in a program. It's a deep valley. We call it an attractor.
Because the ball naturally wants to roll into it.
Right. Once the ball is in that valley, it takes a lot of energy, a lot of force to push it out. That's why breaking a bad habit is so hard. You're not just reprogramming, you're fighting gravity.
And on the flip side, if someone is easily distracted, their landscape might be, what, flat?
Exactly. Shallow valleys. The ball just rolls around everywhere with the slightest little push, no focus.
This leads us to something that sounds terrifying, but is actually essential. Chaos. When I hear chaos, I think of random noise. But in this theory, chaos is a feature, not a bug.
We talk about the edge of chaos. If your brain was perfectly stable, just deep locked valleys, you'd be a robot. You'd never learn anything new because you'd be stuck in your tracks. But if it's too unstable, you're psychotic.
The Goldilocks zone.
You want to be right on the edge. Stable enough to hold a thought, but unstable enough to switch gears instantly if the environment changes. That flexibility, that's chaos.
There was that famous experiment mentioned in the notes about wagging your fingers that proves this self-organization.
The Kelso experiment, it's so simple you can try it right now. If you wag your index fingers slowly, you can do it out of sync. You know, left, right, left, right. But if you speed up, keep speeding up, suddenly snap. Your fingers will lock into a synchronized pattern, both in, both out.
And you didn't decide to do that.
No command was sent from your brain. The system just fell into a more stable attractor because of the physics of speed. It's self-organized. The dynamicists argue that your thoughts, your consciousness, your will, it's all just the system self-organizing.
That is humbling. It suggests that I am not the CEO of my brain. I'm just the state of the system at this moment.
It is humbling, but it's also a bridge. Because for a while, it felt like we had this war, the computer people saying symbols versus the dynamic people saying physics. But now we're starting to see a reconciliation.
And this is the concept of microgenesis, which sounds like a sci-fi term.
It does, but it's really about how these thoughts come to be. Mark Bickart introduces this. He critiques that old computer view. He says, look, a mental representation isn't a static picture in your head. It's an anticipation.
An anticipation of an interaction.
Right. When I see a chair, I don't just see a shape. My brain anticipates if I lower my body, I will be supported. The definition of the chair is what I can do with it.
So it combines the structure, the chair, with the function, the sitting.
Exactly. It bridges that gap. The mind is a system of anticipations, constantly updating based on whether those anticipations work out or fail.
And how does actual neuroscience back this up? Because we have fMRIs now. We don't have to guess like Wundt did.
Well, the old way of reading fMRIs was very phrenology. It was like, oh, this spot lit up, that must be the fear spot. Now, with network analysis, they're looking at the trajectory.
The path of the ball in the landscape.
Yes. They can see the brain moving through these state spaces. And the most fascinating part is neuromodulation. chemicals like noradrenaline or acetylcholine.
I love this analogy. The chemicals aren't just fuel, they're like terraforming agents.
They reshape the mountains. Think about it. You're sleepy or you're bored. Noradrenaline floods in. What does it do? It flattens the landscape. The valleys get shallow. The ball can roll around easily. You become exploratory, flighty, curious.
And then you need to focus. You need to get work done.
Acetylcholine kicks in. It digs the valleys deeper. It locks the ball into the focus attractor. You literally cannot be distracted because the valley is too deep to get out of easily.
That blows my mind. My brain chemistry is actively landscaping my reality in real time. It makes the computer metaphor feel so static, so
A
dead.
computer doesn't reshape its own hardware just because it's curious. We do.
So we've gone from the heart as a radiator, to the periodic table of sadness, to the pigeon behavior, to the desktop computer, and finally, to the dynamical storm, a self-organizing, landscape-shifting storm.
It's a hell of a journey.
So bringing this back to you, the listener, why does this shift matter? If I'm just trying to be more productive or happier, does it matter if I'm a PC or a storm?
I think it matters hugely for how you treat yourself. If you think you're a computer, you think, I just need to download the right data or delete the bad code and I'll be fixed. And when that doesn't work, you feel broken.
Why can't I just execute the Be Happy program?
Exactly. But if you realize you're a dynamical system, you understand that you have these deeply carved valleys, you have momentum, you can't just switch. You have to apply consistent force over time to push that ball out of the valley and carve a new one.
It preaches patience,
Uh-huh.
and it highlights the environment again. Remember Skinner? He wasn't wrong about the environment. If you want to change the landscape, sometimes you have to change where the landscape sits.
You can't terraform a storm while you're standing in the middle of a hurricane. Sometimes you have to move the storm.
So here's a final thought to chew on. If this theory holds, if our mind is just a self-organizing system settling into these attractors based on chaos and physics, are we ever truly the operator of the machine? Or are we just the experience of the ball rolling through the valley? Are we controlling the chaos, or are we just surfing it?
That is the ultimate question. And honestly, if you pay attention to your own thoughts today, just watch how they flow. Watch how they snap into grooves without your permission. You might just catch a glimpse of the landscape.
A terrifying and beautiful thought. Thanks for diving deep with us. We'll see you in the next valley.